Hello, welcome back to the channel. Let's solve another graph problem. So today's problem is from LeetCode 2658, maximum number of fish in a grid. So this is a medium problem, and let's see what's the problem statement. So we are given the zero index matrix grid of size m by n, where R and C, they represent, if the grid RNC is 0, that's a land, or a water cell containing grid RC fish. If a grid RC row and column, if it's bigger than 0. A fisher can start at any cell, at any water cell RC, and can do the following operations any number of times. And number 1, catch all the fish at the cell RNC at the specific cell, or move to any adjacent water cell, right? And return the maximum number of fish the fisher can catch if he chooses his starting cell optimally, or 0 if no water cell exists, right? And the adjacent cell and adjacent cell of the cell RC is one that in 4 directions basically. So this is we are given this the grid. So that grid is it has zeros and it has values bigger than zeros. They indicate the number of fish, right? So then we need to return the fisherman can fish in one island, right? So there are multiple islands in here in this grid. So the fisherman can start at any island and see which island gives the most fish, right? And let's see the constraints. So M and N, they're the lengths, the rows and columns of the grid, and it can range from 1 to 10. It's a pretty small grid, right? So let's see this in the whiteboard. Okay, so we have this grid given, and this all of the 0 cells, they indicate it's land, which means like there is no fish. That's why it's 0, right? So this is a land. We can just count them off. So they are all lands. There is no fish, right? And fishermen can start at any cell, and which we basically need to return which island gives the most fish, right? So this is very similar to the problem that we have already discussed in this series, which is the max area of the island, right? It's almost identical problem. Let's see, what we can do, right? So we can start initially iterating from the first cell. We need to make sure that it's not the land cell, right? Land cell, right? This one is a land cell. Then we go to the next one. For each, this is let's say this is one island, right? This is the from this cell, right? From this cell, right now this is 0, right? This is the land. Then we go to the next one, because that's how we iterate the grid. Then, and from this cell, we check 4 directions, right? So we check left, right is already 0, which is a land, down is a land, up is outside the boundary of the grid, so we can do nothing in there. So this one initially for each island, right? We say island, let's say we count the fish, the number of fish of the island, right? Of the island here, we can see 2 plus 1 is this island is basically giving number of fish is 3, right? Then we from this cell we cannot go anywhere because this is the land outside. For each cell we check. This one is already, once we visit this cell, right? Once we visit this cell, we make sure this is the second cell. We also turn this, we initialize this grid visited, then we say this is true, which is visited cell. Then we go to the second row, and for this cell, and we check if we have already visited the cell. And if it's not visited, then we count the number of fish there. Total maximum number of fish. Initially, we initialize, okay, max fish, right? Max fish count. We initialize 0. Then after we found this maximum number of fish in this island, we update this to 3. Then we come to this to the 4, which is non-zero. Then we check right and up is land. This is land. This is outside the boundary. Then we go. Then we count this one. And after we count both, yeah, let me just also, this one is also true, which is a visited. Then this island is basically giving us number of fish 5, which is greater than 3, right? If it's greater than 3, then we update this one. Then we also have to label or mark these 2 cells as true and true, right? True means like that's a visited cell, right? Then after we just go here to this cell, because this is all land cell, we need to make sure that it's not a land cell. And from this cell, we just go up, check, and this check, and this check. And we can go here and here. This is outside boundary. Then we also add this one to 3. Then this island is giving us 7, which is 7 is bigger than 5. And we return 7. Then we mark this 2 cells as visited, which is true and true. Then we go to the last row, which is, this is also land cell. This is a land cell. Then we come to this cell, check all 4 direction, right? 4 direction. Then this one is not visited. We add, and this island basically gives us the 5. Then 5 is not larger than 7, so we just kept the 7. Then we return the 7 as an answer, right? To basically check all 4 directions, we need to check directions. We can do list, right? So 1, 0, and this goes to the row down, and 0, 1, then 0, 1, 1, 0, minus 1, 0, and 0, minus 1. Like this 4 direction, it gives the movement of a fisherman, right? And the fisherman can only fish in this in the water, right? So this one we found this is true. Then we also visited this true. Basically, this is we are doing this now with the breadth first search, right? BFS. So what we do, we initially start from the very first water cell, which is this one. Then let's just take this one, and we add this to the queue, right? To the queue. Then we check all of its neighbors, and return all of the like maximum cells, right? So this is basically that's how we go, and we will look at the code, and I think code will make the things much clearer. Okay, so let's look through the code. Initially, if there is no grid, right, then we basically return the maximum number of fish is 0. Then we compute the number of rows and the number of columns. Then we initialize the directions here, 4 directions. Then as we initialized here the visited grid to mark if the cell is already visited. So that's how we initialize this this visited grid. Then what we do, we initialize the max fish count of to be 0. Then we start iterating this grid from first row and first column, and go for entire row, entire column. If the grid is not 0, which is bigger than 0, right, we check this one. And if that grid is not visited, basically we are checking this two grid, right? One is we are making sure that this is not 0, which is a land, and also we are making sure that this is not false, right? Which in that case will be the second cell, right? So this is not visited. Then what we return this max fish count is going to be the max fish count initially 0. Then we return this BFS, the grid, row, and the column visited. This will return the number of fish in the island, right? So then we basically return the maximum fish count. And if we go through the BFS, it's a typical BFS with the queue. Yeah, not to use the self, I just initialize this number of rows and columns again here, and directions, I think that direction can be removed. Then for each island, we initialize the fish count to be 0. Then we add that start column and the start row to the queue, and we mark that cell to be visited, right? Then while the queue is not empty, we pop that queue to get the row and column. Then we add, because we already are checking that it's not non-zero, right? Which means that there is a fish. If there is a fish, then we add that number of fish of the cell to the fish count of the island. Then from that specific cell, we check for directions, right? And if the dr is a row and dc is a column in the directions, then we compute the neighboring row and neighboring column by simply adding dr and dc. We're basically checking from this cell all let's say all four direction, right? All four direction. So after we check this all four direction, we need to make sure that we are still within the boundary of the grid. Suppose new neighboring row and the neighboring column, they are within the boundaries of the grid. Then we also check if that's not a land cell, right? If that's a land cell, then it will be 0, right? Then we don't need to go through that cell again. So basically this is if this is not 0, and also if that cell is not visited, right? If that cell, we already marked that cell to be true, so we don't want to just go through that cell again, right? Because we have already, that cell was already part of another island, right? Of the same island. Then we mark that cell to be true. Then we add that neighboring row and neighboring column to the queue. Then this we process this until the queue is empty. Then at the end we return this fish count. This fish count will be the fish count of the specific island, right? Then this will be returned. This will be returned. This inside this one, self BFS. This will return the fish count of specific island, right? Then this will be specific island fish count, let's say 3. Then next one, if the 5 is larger, then we just get the maximum of the fish count of each island, right? Basically this is the entire code. And the time and space complexity, we are just iterating through the grid just once, right? Then it will be basically O of m times n. This is time complexity, and space complexity will be m times n2, right? So this is it for this problem. I hope this is clear. Explaining this in in the notes, and also walking through the code. And if you guys have any questions, please feel free to share in the comments in the video. Okay, thank you. See you in the next video. Bye.